Hey class, we're back at it here, continuing with page 3 in section 5.3, talking about 45, 45, 90 triangles now. Again, here's another one that's worth memorizing. In a 45, 45, 90, if we made this side 1, this side would have to be 1 as well, using properties from geometry. Because the angles are the same, 45 and 45, the sides have to be the same as well. So no matter what you choose, if you choose the side to be 3, they're both 3. And then with Pythagorean theorem, you could work it out, and this is going to be root 2 over here. Okay. So this one use for doing examples like below. Find the 6 trigonometric functions of a 45-degree angle. Again, we're using the SOHCAHTOA, right? So the sine of 45 degrees. In this case, it doesn't matter which 45 angle we use, so let's just use the one down here. The opposite is 1, and the hypotenuse is root 2. 1 over root 2. Multiply top and bottom by root 2 would leave you with root 2 over 2. I really did not leave myself a whole lot of room for the 6 trigonometric functions, but we'll squeeze them in. Cosine 45 degrees is going to be the same, right? Now we're talking adjacent, which is this one here, and is over root 2, so it's the same. All right. Okay. Tangent 45. Remember, tangent is opposite over adjacent, TOA. So 1 over 1. 1 over 1 is 1. All right. Now we just need the 3 reciprocals, which goes a little faster, right? Because cosecant, hey, not 30. We're on to 45. Cosecant 45 is the reciprocal of this one. Right, so just flip that over, root 2 over 1, just root 2. Secant would be the same. Secant 45, root 2, because we're flipping over the cosine, which is the same. And then finally, cotangent. Cotangent 45, flip 1 over, you get 1. Right? It's the reciprocal of the tangent. All right. Summarizing this, then here's a little table that might be useful to you for a reference. It gives you the values of the trig functions for 30, 45, and 60. And it's just sine, cosine, and tangent. If you had to find secant, cosecant, or cotangent, you just flip these over, right? Flip the right one over. And so this is a helpful little tool. Okay. For example, if you had to find cosecant 60, we could draw that triangle out and use a 30, 60, 90 triangle, or just refer to this. Cosecant is the reciprocal of the sine. So there's 60, there's sine, it's root 3 over 2. Flip that over, it's 2 over root 3. And then rationalize. Since I got the room, I'll just show my work. All right. That's going to be 2 root 3 over 3. Okay. Next, reference angles. Okay, so a reference angle for an angle, now we're going back to the standard position, the Cartesian plane, XY axis. It's an acute angle, positive, made by the terminal side and the x-axis. So those are the key words there. Positive, acute, made with the x-axis. So if we look at, let's say an angle is here in quadrant 2, there's your angle, right? Then the reference angle is the one in the red with the apostrophe on it. It's the angle made with the x-axis. It's acute because it's less than 90. And that'll be of use for us when we get into more problems, okay? So notice all of these, the angle is made with the x-axis and it's an acute positive angle, right? Doesn't matter which direction your arrow is going. It's always going to be positive, okay? So don't worry about counterclockwise, clockwise for reference angles. Just always positive. Okay, so I just described that, but that's the important thing. It's always with the x-axis, not the y, right? So finding reference angles, it's pretty straightforward, I would think. So like if it helps to draw it out, like 120, just you got to know where 120 is, right? So something like right there, right? There's be 120 degrees, right? 30 degrees past 90. The reference angle is over here, right? So remember this, if I went all the way, that's a straight angle of 180. That's 120. So the difference would be in here. So the reference angle would be 180 minus 120. So 60 degrees. Okay. How about negative 135? Negative is this way, right? There would be a negative 135. The reference angle is here. Okay. So kind of similar, right? What is that reference angle? What is the difference between this and this, right? That's 135. All the way around, like this would be 180, right? This is 135. So what's that? I could still do the same thing I did over there. Right, to calculate that out, just do a little quick math. 180 minus 135. 45 degrees is the reference angle. Notice my answers are always positive acute angles. Oof, 713. That's some rotation there. So you might want to get your calculator out for that one and subtract off 360. 713 minus 360 is a 353, right? So 360 is, we'll do it once around, right? And now I got to go 353. Almost a 360 again. There's that angle. So I just drew the angle 713. The reference angle is this a little angle in here, right? And so I can calculate that because I know full circle is 360. I just went 353. So I would do 360 minus 353, 7-degree reference angle. Acute, positive, made with the x-axis. All right. Moving along, all of this comes together in these problems. The reason for 30, 60, 90 triangles and reference angles, and all of that is finding exact values of trig functions of angles that are multiples of 30 or 45, or we're going to call those special angles. So if you ever see that term special angle, a special angle is a multiple of 30 or 45 degrees, because then you can use those 30, 60, 90 triangle properties or the 45, 45, 90 properties. Okay. And here's some steps in order to accomplish that. All right. So what if we want to find, let's just get right to an example, the 6 trig functions of 240 degrees. Let's just start with sine of 240. Okay, we'll get to all 6. So I left plenty of room here. Probably not enough though, because we have to get all 6 of them. But I'm gonna blow it up, so make it a little smaller. All right, 240 degrees. The first thing you want to do, if I look at those steps, is draw it. All right, where is 240? Okay, so I'm gonna draw it out. Right, and if you want to even blow it up so you can see it better, 240. Like remember, here's 180. So 240 is 60 degrees past that, right? Okay, and then it's useful to draw a triangle to the x-axis, right? And then label that reference angle. So I'm following the steps here. Whoa, sorry. Right. So step 2, draw a triangle to the x-axis. And then step 3, label the reference angle. So those are my first 3 steps. Okay. So let's go back to that triangle. Hope I'm not making you seasick here. That's 60 degrees, my little reference angle in there, right? If that's 60, and that's 90, then this has to be 30 because they all have to add up to 180, right? You've generated a 30, 60, 90 triangle, all right? Next step, label the sides of the 30, 60, 90 triangle. Use that special triangle that we said, hey, we should memorize this. Use that here, right? Opposite the 30, we're always going to make 1, hypotenuse 2, and opposite 60, root 3, okay? Then include negatives if there are any. Now the hypotenuse is always positive. That's never going to be negative. But if your X or Y value is negative, you want to put that now, right? So this is actually a negative one because you're going to the left on the X-axis. And this is actually negative √3 because you're going down. So anytime you go left or down from the axes, you're going to put a negative. Okay, so we've got it. We've just labeled our little triangle. We've done steps 1 through 4, right? We did use negatives where appropriate, got it all in there. Finally, now we're going to use those definitions of the 6 trig functions. Now, which definitions you use is up to you. You have 2 sets now. You have from 5.2 with the ones with the x over r, y over r from the last section, or you could just think of it as the opposites and the hypotenuses, as long as you use the reference angle as your angle that you're doing. I'll kind of talk through both of them. So if we're going to do, let's blow it up again, sine of 240 degrees, you have 2 ways of thinking of it, y over r or opposite over hypotenuse. Okay, I don't care which one you're thinking, you know, both of them will give you that same ratio. So y over r is negative √3 over 2. Right? So y over r is negative √3 over 2, or think of it as opposite over hypotenuse of the reference angle. Okay. All right. So either way, you're going to get negative √3 over 2 as your final answer. Okay. Cool. All right. Now do all 6. See what you come up with. You can hit pause and try these on your own, and you can compare with mine, or I'll just keep going. Cosine of 240 is x over r. Seeing it? Or adjacent to the 60 over r, right? Either way, you're going to see that negative 1 over 2. Okay. Tangent 240 is opposite over adjacent, or y over x. It's the same 2 numbers. Opposite is negative √3. Adjacent is negative 1, or y over x, same numbers. Negative √3 over negative 1. The negatives cancel. You don't need the 1 because it's in the denominator. There's your final answer. Okay. That's the hard work, right? The rest are just reciprocals, which might the only thing you'll have to do is maybe some rationalizations or something. But the cosecant of 240, you're just going to flip over the sign and then rationalize it. Right. The secant of 240, flip over the cosine, it's going to be negative 2. I don't need to write the 1 in the denominator. And then cotangent of 240 is 1 over √3. I guess they're still both negative, right? Rationalize it would be √3 over 3. And we've got all 6. All right. So those are the exact values, exact because we're not using decimals or an approximation or anything, of the 6 trig functions of that angle of 240. All right. All of these are going to be quite similar as you go through. So if you want to try these out before looking at the next video, go for it. But I'm going to pause here and I'll start back on the next one. That gives you a chance to do them if you want to try them first and then follow along in the next. All right. So I'll leave that up to you. Anyway, send questions my way. I'm here to help. Hope all's well. Talk to you later.